everybody. I'm Meltem Ballan, Data Science Professional Fellow from General Motors. It's great to be here and talk to you from my home office. Thank you very much for the invitation and being my guest this afternoon. I'm very excited to talk to you about future of mobility and connected vehicle data. Before I start with my talk, let me give you a quick overview of what to expect today. I'm going to start with GM views of the future of mobility. I will provide a sneak preview of history of vehicle industry that you might never heard before or familiar with. I also want to remind you about the forces shaping connected future and resulting changes in the industry and information age. That will lead us to connected cars with some numbers and use cases. I will close my talk with a quick view of how the connected cars are leading us to autonomous world. Don't we all want 3 zeros? How hard would it be to get there? My team and I look for answers in the data. We collaborate with local government officials, universities to build an informed road network to hit the zero crash goal. We investigate fuel usage and pollution metrics, and lastly develop models to identify possible routes and proactively inform our customers to avoid congestions. Aren't all those addressing EV and autonomous future for us? I promise, I'll take you there. But first, allow me to tell you about the journey. I love old movies and wanted to show a video from 1956 Futurama. The technology didn't allow me to share my video though, so please allow me to summarize the video with one sentence. But if you're like me and enjoy how the technology developed, visit YouTube to watch the video. GM showcased the Firebird with autonomous driving features and route control system in 1956. However, the journey started centuries beyond that. Did you know, aside being a great artist, Leonardo da Vinci was an accomplished scientist developing theoretical models for locomotion and transportation. He's the first to design a self-propelled cart. The cart was powered by coiled springs, and it also features steering and brake capacity. When the brake was released, the car would propel forward and the steering was set to go either straight or a preset angle. Physicists in 18th and 19th centuries designed fuel and EV engines. But until 1913, only the small segment of society were able to benefit from vehicles. All that imagination and prototype became approachable for everyone with Ford Model T mass production lines. With the war hitting in 1940s, the car industry switched from personal vehicles to war vehicles. The switch also helped the industry to become more integrated with technology, like in mobile radios, remote control technologies, as well as simulation. The modern cars with luxury and safety features date back to 80s. It is continuously developed until 90s. Slow switch from all mechanical engineering to technology and data started in 2000s, creating new opportunities for software engineers, data engineers, and data scientists. And it is all growing fast. Oh, before I forget, you should definitely go visit Florence. Stop by at Heritage Museum to see Da Vinci's design after the world gets back to normal. Scientists and engineers finally built a working model of Da Vinci cart in 2006. As Dennis Waitley famously said, imagination plus innovation equals realization. But process takes time and priorities define the speed. Yes, these changes have not happened overnight, and it is highly correlated to forces. Newcomers like Tesla is a great example for OEMs to reconsider the EV directions. Regulators like Federal Highway Association, Department of Public Safety, and organizations like Motor and Equipment Manufacturers Associations are the main internal forces. Economy, human, driving preferences, and demand are the main external forces. For example, in the bigger cities, people prefer the ride share instead of driving. Today, people are more interested to own one multi-use car, whereas they had 2-3 cars for different functions in the past. Technology has become part of demand, and optional safety features became the standard. These forces enabled different disciplines to come closer and work together. Information age itself had a long run. Information age started with first computers. The first shift started in the 20th century from industrial revolution to a digital economy. Industrial sectors became more aware and collaborative. For example, car OEMs and computer chip OEMs started to work closely to empower the cars to serve better for consumers. CRM is a good example of bringing together product and services. Users became the partner of producers. IT became part of non-IT departments like marketing. Digital marketing term has become more common than marketing. Science and industry started to work side by side. For example, GM collaborates with a lot of universities, and my particular initiative with UT Austin is to enrich our data using open source tools. Science disciplines became partners. It's all for humanity, and people started to have common digital platforms for more efficient communication. So the obvious question would be here, why now? With developments and advancements in digital technologies, dealing with high-volume data has become much easier. The change has been so rapid, growing machines to talk to each other. IT became commodity and part of digital mode. The digital sensors with Wi-Fi capacity have become more affordable for OEMs without raising the price of vehicles. OEMs started to invest in backup storage systems and memory for analyzing the data at minimum cost. Literally, the mobility is in our fingers. Let's look into connected vehicles closely. Isn't it look like a super smartphone? It is true that we use similar technologies like a smartphone. The signal on vehicle boards are transferred to our servers via Wi-Fi networks, and it includes infotainment systems and some driving habits. As you can see, since we are reaching to the full 5G technologies, we are getting more and more data every second. An obvious benefit of this platform is informing its drivers, like a cell phone app, sending diagnostic reports real time. Moreover, the vehicle data collectively provides patterns and information for drivers, local governments, and companies. I'll touch base on different use cases going forward. There are definitely challenges to get meaningful data and analyze it in the best possible manner. The data is transferred by sensor boards, and it pretty much looks like ones and zeros. The meat of the signal for us is just the 25% of entire signal. This format coming out of vehicle is intended for engineering, safety, and diagnostics. After several stages, it becomes human-readable information. 25% from each vehicle contributes to create a mountain of data. This number is projected to bypass the billion marker in 2034. Let me start with the personal benefit of getting data from the vehicles. Please don't judge me that I have not taken my vehicle for maintenance. This is the latest diagnostics from my vehicle. It tells me to take care of a couple of things. First, oil life and the tire air pressure. Yes, yes, I definitely promised that I changed the oil and added some air to the tires. And also, I washed the car. As a consumer, I benefit from some other connected vehicle services. I want to share some of my experiences. GM is very good to us and provides us company vehicles to showcase and test. It was 2 years ago, my first trip with my first company car. I was driving an SUV when I stopped at the lights. A small sport car was turning to right and didn't slow down at the lights. He simply hit my car from the rear end. The front of vehicle was literally skated under my car. I was shocked. I unexpectedly heard a friendly voice. Are you okay? It was definitely great to hear the OnStar agent as I had no clue what to do. I don't think I mentioned, but I live in Austin, Texas. Austin is definitely famous with its bad traffic, if nothing else. The live navigation assistant and warning system gives me peace of mind to avoid road construction and accidents. Another favorite of mine is remote start in Texas heat. I definitely give my car 10 minutes to cool down before I get in. I wish I could also hear your preferences, but it has to be another time. Up until now, I was looking at this data from the consumer perspective. But here, my job starts. Connected vehicle data collectively reveals road and safety patterns. In my world, we are committed to maintain high privacy standards. We anonymize the personal information of our drivers who opt in for our data collection pool. Here it is an example of fictionalized data product. Let's say we score the road and identify the addressable maintenance and repair for local governments. The map shows urban and rural areas, and red dots shows near real-time high-priority road segments for maintenance. It provides a proactive perspective for improvements of rural roads. We use vehicle identity like body types, weight, and fuel, driving style, and road-related signals like suspension responses, pothole, and quick turn to come up with GM connected vehicle scores. The connected vehicles, specifically the real-time location-based information, is filling the data gaps that local governments are missing. In the current scenario, local governments rely on surveys to identify the road safety and maintenance need. They subcontract companies to identify the potholes and structural road issues. Cameras and radars are used to address safety issues like where to put a pedestrian road, or road signal, or lights. The data is limited to selected locations, spotted, and there's a time lag between collection and analyzing of that data. It can be up to 2-3 fiscal years to act on it. Connected vehicles have continuous coverage as part of the data contains emergency and diagnostic information that I showed. The frequency of data is within seconds and provides governments accuracy and consistency for road segment analysis. The implementation of the connected vehicle cars are not only limited to local governments, but entertainment analysis and geospatial marketing analysis, insurance, crowdsourcing, management for dealers, connected mobility from personal vehicle to scooters. My personal favorite is the entertainment analysis. I used to drive between Austin and Dallas for work. I had to constantly change my FM channels to find local NPR station. With lot more information and a little bit of driver preference, the vehicle can adjust radio stations as I drive. All in all, the connected vehicles are actually providing an experience for drivers and stakeholders. Today, it is possible to get sensors with Wi-Fi capacity without high cost. There are a lot of public and private cloud options for OEMs out there as well. The computation power of these cloud environments allows us to implement complex algorithms. I have a couple of minutes to give you a perspective of where all these data are taking us. You know what I'm hinting here. All we're talking about is driving experience and different responses. When we drive, we learn from environment and then react to that environment. All those responses are actually collected as driving and road patterns. The slide shows a caricature way of our decision making. Let's say we're turning right. We start processing information and determining whether it is go or not to go. So what it means. Is there a traffic light? Is it green? Is there a pedestrian or a biker or an animal? Then we collect and mix all these inputs and take action. If nothing is alarming, we turn right and keep driving. We collectively record all the experiences at that right turn spot to build AI models for autonomous vehicles. Since I have a limited minute, I will quickly give you a couple of AI models that we employ. We use techniques like autoencoders to implement new experiences in the machines and help machines to react to unexpected environments. In these scenarios, reinforcement learning plays an important role for machines to respond to the environment accordingly. Recurrent neural network uses internal stages of current situation leading to the decision making. The bottom line is that we are gathering connected vehicle data, learning from mountains of data, and building advanced models. What it leads to us is a safe, autonomous world. In fact, future is now and bright. Thank you for joining me. I would love to continue conversations via email or my social media channels.